Hey guys, so I'd like to talk about statistics, and first of all, I'd like to tell you that I won't be covering the basics of statistics, things like nominal data and continuous data, because I think that by itself is not really clinically relevant, and I'd like to direct my presentation today more on clinical application of statistics, and I think that's pretty very useful for the exam. And as requested, I've based a lot of my presentation on the Copernicus study, which is a study that was released in 2002 and had about roughly around 2,000 plus participants. And it was on investigating the effects of carvedilol versus placebo in congestive heart failure patients, New York Heart Association class 3 and 4. And it was testing the primary outcomes of annual mortality and secondary outcomes of hospitalization and adverse events. Okay, so before we go into that, let's go into the basics of statistics, the basic, clinical statistics. Probability. It is defined as, the likelihood of an event happening. So, for instance, the probability of rolling a 1 on a dice or a die is 1 out of 6. Okay, and that's pretty straightforward. And why did I go into this? Because it's relevant in this describing about relative risk, which is the risk of developing a disease after a certain exposure. It is defined as probability of the experiment over the probability of control. Okay. Now, how does that apply in medicine? So, for instance, let's go into the Copernicus study again, where the probability of experiment on the carvedilol arm was 12.8%. Now, this is in terms of outcome of death, whereas the placebo had the outcome of 19.7%. So, from that, we can calculate the relative risk, which is probability of the experiment over control, and we get 65%. Okay, so the risk of death in heart failure in patients on carvedilol is 65%. So that's the continuous mortality. Okay. Now, that isn't as relevant as the relative risk reduction, which is defined as the difference between the likelihood of an event between two groups. Okay, that is mathematically defined as the sum of the total of the probability of the control minus the experiment over the probability of control. Of note, the summation of relative risk reduction and the relative risk is 1. Okay. So let's apply this back to that study. We've gathered that the relative risk is 0.65 or 65%. Now, the relative risk reduction in this study, in the carvedilol arm, is 0.197 minus 0.128 over 0.197, which equates to 0.35 or 35%. So this means being on carvedilol reduces the risk of death when compared to the placebo by about 35%. Okay. So that's the relative risk reduction. Now, there's another important term that's quite important, that's fundamental in most research, which is the absolute risk reduction. It's also called the risk difference. It is the change in risk of a treatment when compared to the control. Now, an absolute risk reduction is the probability of the control minus the probability of the experiment. Okay. Now, in the Copernicus study, the absolute risk reduction equates to 6.9% based on the calculation. Okay. So what this means is the risk difference. Okay. So the risk difference of being on carvedilol when compared to placebo in mortality outcome is 6.9%. Now, the absolute risk reduction is not as important as the last thing I'd like to talk about before I go on to the next topic, which is the number needed to treat. Because you need your absolute risk reduction to calculate your number needed to treat, which is defined as the amount of person or persons needed to be treated with the intervention for one good outcome. So NNT equals to 1 over absolute risk reduction. And it is considered as the best predictor of outcome for studies because it is easily understandable and it is easily translatable in the real life. There's also a number needed to harm, but that follows the same calculation, but it's testing a different thing. Okay. Now, in that Copernicus study, we had our ARR, or absolute risk reduction, at 6.9%. So the number needed to treat for being on carvedilol is 14.5. So what that means is for every 14.5 people treated with carvedilol, one patient will have the added benefit of not dying over the period of the study. So you want your number needed to treat to be as low as possible. Okay, and 14.5 is quite a good value. It's not bad. Okay. Now I'll just quickly skim about odds, just because you can't talk about risk without talking about odds. And odds is defined as the probability over 1 minus probability. And the higher the odds, the less likely the outcome will be. So for example, in rolling a 1 with a die, or a dice, that's 1 over 1 over 6, because the probability is 1 over 6. Sorry, so it should be 1 over 6 over 1 minus 1 over 6. And that equates to 0.2 or 1 over 5. So the odds of rolling a dice is 1 to 5. Okay, and this is the same, sports betting odds that you see, online or on newspaper and stuff. It's the same thing. So the higher the value, the less likely the outcome will be. Okay. And the reason why we talk about odds is because you need to know about odds ratio, and now we don't actually use that a lot because it's only used in linear regression studies or case control studies, and it is defined as the ratio of odds of an event occurring after a particular exposure. So it's the odds of the experiment over the odds of control. Okay. Confidence intervals. Again, pretty straightforward, is the range of numerical values in which we are confident that the population value will be within those intervals. So for instance, 95% of the world's IQ, the world's population's IQ will be between 70 to 130 because the standard deviation is 15 points. And it is also useful in determining whether the results it's valid. Okay, so for instance, in the Copernicus study, the relative risk of the carvedilol group is 0.65 with a confidence interval of 0.52 to 0.81. Now the value is less, the relative risk value is less than 1, certain less than 1. So what that means is it is a valid result to prove that carvedilol reduces the risk of has a lower relative risk compared to the placebo. Okay. And p-value, on the other hand, is the probability of an outcome is due to chance. So a result that is statistically significant will have a p-value of less than 0.05. And it's highly dependent on not just the outcome, so the results, but also on the number of participants. So the higher the n value, the higher the numbers, the better. Okay. And the lesser the p-value, the greater its significance. Okay, so for instance, in the Copernicus study, its p-value is 0.00013, so it's very, very unlikely that it can be the result was due to chance. Okay. So as a conclusion, in regards to the Copernicus study, which is carvedilol versus placebo in reducing the risk of death or hospitalizations in New York Heart Association Class 3 and 4, its relative risk is 0.65 with a 95% confidence interval at 0.52 and 0.81, which we've covered before. It had a p-value of 0.00013, which means it's statistically significant, and has a number needed to treat of 14.5. Okay. All right. Now to the next part of the topic. We'll talk about sensitivity, which is actually a measure of the ability of a test in determining the number of actual positives in subjects who have the disease. Okay, so from that table there, it is defined as the number of people who have the disease and test positive over the number of people who have the disease. So that's A over A plus C. Now, this is where the mnemonic snout comes in. So in tests that are highly sensitive, a negative result can rule it out. Okay, so snout. Now, specificity on the other hand is the ability of a test to determine actual negatives in subjects who do not have the disease. Okay, and its specificity is defined as from the graph D over B plus D, and the mnemonic spin means if a test is highly specific, a positive result can rule it in. Okay, so that's for highly specific tests. All right. So examples of this would be, in diagnosing lupus, the ACR criteria is 97% sensitive, but 84% specific. Okay, that means if you're negative with the ACR criteria, you're quite certain that you can rule it out. Okay, the CA125 tumor marker has a sensitivity and specificity of 78% in diagnosing ovarian cancers. It's not highly specific or sensitive. And the FOBT test, in detecting bowel cancer has a very low sensitivity of 66.7%, not very low, but a relatively high specificity of 91%. Okay. Predictive values is a probability of the patient having the disease when they test either positive or negative. Okay, and accuracy is determined by the number of true positives plus the number of true negatives over the number of participants, expressed as a percentage. Okay, so from the same table that we had before, a positive predictive value is a number of people who tested positive with the disease over the number of people who tested positive, and vice versa for the negative predictive value. Okay, and an example of a test that has a high negative predictive value is a D-dimer, which has an NPV of 94%. So in patients who are intermediate and high risk patients for DVT, so according to the Wells score, a negative test can safely exclude DVT. Okay, and accuracy, and the accuracy is defined as A plus D over the total sum of subjects. And false values equates to type 1 and type 2 errors. It's not really used much in terms of clinical statistics, but it's more of a mathematical term. Okay, so this is a summary of the same table as I said before, where you've sensitivity and specificity is along that axis, whereas along the horizontal axis, you can test your PPV and your negative predictive value. And again, accuracy is defined as true positives and true negative over the sum of total subjects in that experiment. Now, on my last part of this first presentation, I'd like to talk about the Fagan nomogram. Now, I used to hate this nomogram. But then now that I've seen it applied clinically in a few different cases, I think it's extremely useful. So the main function of this Fagan nomogram, it has 3 linear scales, which requires the pretest probability and the likelihood ratio for you to calculate the post-test probability. So this is to test what is the probability of the person having a disease if they test negative or positive. Okay. So in calculating the post-test probability, you need 2 things. Your pretest probability, which is defined as the prevalence of a disease in that population, depending on the set parameters that you have. So that means if the patient patient X has this disease with this and this parameters, what is the prevalence of that disease? okay, and a likelihood ratio. So if it's positive or negative, okay, and a positive likelihood ratio is calculated by sensitivity over 1 minus specificity, whereas a negative likelihood ratio is 1 minus sensitivity and over specificity. Okay, so how do we apply this clinically? So I'll give an example there. For instance, Mr. X, okay, has a family history of bowel cancer and he smokes. Okay, so in patients with a positive family history and smokes, the prevalence of bowel cancer in those patients are 3%. So this is based on a different study. Okay, so that's 3%. That's the prevalence. Now he decides to take an FOB test, fecal occult blood test, which has a sensitivity of 66.7% and a specificity of 91%. Now, what are his chances of having bowel cancer if he tests either negative or positive? Okay, so let's put that, let's calculate that. So the pre-test probability, which is the prevalence, is 3%. And from those from those previous formulas, I've calculated the positive likelihood ratio as 7.4, whereas the negative likelihood ratio is 0.37. Okay, so let's put that back in the Fagan nomogram. So the pretest probability was 3%, and if we're testing for if Mr. X tests positive, okay, so we'll take the likelihood ratio of 7.4. So when we cross the line through those numbers, we get his post-test probability being around 18%. Okay? Whereas if we test it negative, so we take the negative likelihood ratio of point something, his post-test probability is around 1%. Okay, so that's if he tests negative, the likelihood of him having bowel cancer is less than 1%. Okay, so from that, as a conclusion, if Mr. X tested positive on his FOB test, his probability of having bowel cancer is 18%. Whereas if he tested negative, the probability of him having bowel cancer is 1%. Okay? So I hope that concludes the first part of my two-part lecture. I will be posting up my next lecture soon. Okay, see you guys. Bye.